Welcome to the damped mass on a spring video. In this experiment, we'll be oscillating a mass on a spring in air and water and measuring the respective damping coefficients. In exercise 1, we'll be measuring the spring constants using Hooke's law.
Attach a force sensor to the bottom bar. Connect the spring to it and to the top bar. Attach the motion sensor to the top bar so that it faces downward, making sure that there is nothing between it and the table. Connect the motion sensor to digital channels 1 and 2, making sure yellow is in 1.
In Data Studio, add the sensors as appropriate. Ensure the sample rate is set to 250 Hz and the force sensor is set to medium sensitivity. When you press start, you should hear the motion sensor clicking. Move your hand back and forth to ensure that it's working.
In Data Studio, create a force versus position graph and press start. Press the tare button on the force sensor, loosen the upper bar, and pull it upwards, stretching the spring. This should result in a linear graph with slope k. Note that if your force is negative or your graph is otherwise unsatisfactory, be sure that you properly calibrated your force sensor and that you pressed tare immediately before taking data.
In exercise 2, we'll be capturing oscillations of a mass on a spring in air and water.
In Data Studio, create a force versus time graph. Press start and set the mass in oscillation. Record the decay of the oscillations, making sure that you record a sufficient amount of data.
Next, place a bucket of water such that the mass is fully submerged in it. Lower the bar sufficiently that the mass won't oscillate higher than the water's surface.
Once again, press start in Data Studio and set the mass in oscillation. Again, it is important that the mass does not breach the surface. Be sure to record sufficient data to find the damping constant.
For exercise 3, we'll be determining the mass required to achieve critical damping in both air and water. To do this, we will reuse our data from exercise 2 and repeat exercise 2 for many different masses in both air and water.
Have you got mole problems? Call Avogadro at 602-1023.